This is new to me. I haven't actually had a go at this. Oh, wow. Oh, wow. That's fascinating.
As you can see, it's very smooth.
Hey, Walter.
Hello, Roger.
Welcome to Classic Engine Workshop. So this is where it all began for the use of Wagner products for me, in that we build these fantastic engines for very lucky customers who have classic and sports cars at the valuable end of the market. In front of us, we've got an FIA AC Cobra. This is just an example of the kind of engines that we build here. We also build Jaguar and Mercedes and Porsche and Aston Martin engines. And these are all engines which there's a great deal of effort and energy that goes into making sure that they're absolutely perfect. They have to be very carefully machined. Everything is measured. They're dry assembled 3 times before they're properly assembled, and all the tolerances and dimensions are all very important. So it's really important to me that once these engines are assembled, that after that they're run in correctly and that they have a long lifespan for the customer. So this is where it's really important for me to choose the products which go into them, because the oil is the blood of the engine.
Yeah, I've been in the lubricant business since 30 years, and I developed a unique concept to reduce friction, to reduce wear, to prolong the lifespan of the engine, to keep a smoother engine run, to get a better torque, a better acceleration, and more horsepower.
Indeed, and additionally reduces noise and heat as well in the engine.
This is the final result of it.
Yeah, exactly. Overall, that's how it
So
works.
this year I'm celebrating the 30th anniversary of my company.
Yeah.
And in the mid of the 90s, I came up with an idea how to protect the engines or any lubricated parts. Yeah.
Motor läuft ruhiger, läuft leiser, leistet auch mehr. Und wir haben noch mal eine Preistafel, die wollen wir uns auch mal angucken, denn da sind noch mal detailliert.
So in that time, a lot of solids was in the market. For example, graphite, molybdenum disulfide, and also in the mid of the 19 Teflon, PTFE came up. And they're flooding the market. And I have seen there is a lot of issues with that. For example, graphite is poor carbon. It burns by 450 degrees Celsius. So in the engine, on the piston head, you have much more temperature. So what is the result, or what is the effect? I think it's gone.
Yeah, exactly. Yeah, it's burning.
And the same is molybdenum disulfide, which has been used in decades. And the idea came up with Teflon in the 90s. And we have the same situation, because Teflon or PTFE melts by 320 degrees Celsius plus. And causes another issues. And then I came up with an artificial solid. I name it microceramics. It's chemical inert lubricant solids. Withstands 1100 degrees until it's gone oxidizing. And this temperature will definitely not have in the engine.
That's right. So what we tend to see, maybe maximum temperatures around the exhaust valve and around the crown of the piston, around the top piston ring and so on, we're not seeing much above 800 degrees. So with 800 degrees as a maximum temperature that you could expect to see in a running engine under high load, that your product doesn't break down and it resists all of that sort of stuff. It's really interesting, because whatever brand that you're loyal to, whatever oil that you put in off the shelf, that does not have the full level of protection that you can achieve by adding this solid lubricant. So the solid lubricant itself gets in between all of the metal surfaces as they're working, and it converts it almost from a plain bearing to a rollerball bearing at a tiny scale.
So this is the right explanation, right?
Yeah, so they're tiny little balls that roll one over the other, and you need a microscope to see them, right, if they're down at this nano level. And what that gives us then is a way of improving the lubricant qualities of any oil, including the top brands, including the best oil you can buy on the market from the shelf.
Look, I have here the solids here.
Yeah.
That you got the feeling. Please check it out.
Yeah, well, this is new to me. I haven't actually had a go at this. Oh, wow. Oh, wow. That's fascinating.
As you can see, it's very smooth. Yeah.
It's extremely smooth, and it's immediately coated all of the grooves in my finger.
Yes.
And now I can't touch my two fingertips together because they're separated by this layer, which has immediately gone shiny as I'm polishing it.
As you can see, it's very smooth. Yeah, it's not abrasive. Yeah?
No, it's fascinating.
And
It's
the amount we add, is such as huge that we are implemented these solids into the metal surface. Along, we have a huge amount in the oil, which swims in the oil.
Yes, is in suspension within the oil. Yeah.
We have a spherical shape of it.
Yeah.
This means the solids acting as a ball bearing.
Yeah.
Anytime.
Yeah. And I can feel that.
Yeah.
You can feel that between your fingers. It's an almost extraordinary feeling. It's not like an oil. It doesn't feel like an oil. It feels almost polished, like my fingertips are polished.
You're right.
It's a very weird feeling. It's not the same as if I've got just ordinary grease on my hands. It's a weird feeling. So
and this effect we have everywhere. We have lubricated parts. Yeah. And enhances as much you can't imagine.
Yeah.
So we are breaking down the oil temperature. Yeah. We are breaking down the friction. We are breaking down the wear. So it affects in a better acceleration, more torque, more horsepower. Less noise, less oil temperature.
What really interests me about the Wagner products is how you've used them not only in classic and sports car, but also in agriculture, in marine applications, other applications where if it didn't work, they wouldn't use it because it's about money. It's a commercial decision to use this product. So this reduces wear, it reduces temperature, running temperatures, noise, all of those kind of things. And overall, what that gives you is a financial benefit, reduced maintenance, longer service intervals, all of that kind of stuff. So it's an incredible product.
Yes, the money you spend, you will get back in a short time.
Yeah, exactly. Yeah, and actually, it's a small cost to add this. I mean, we're looking at the moment. So this is 500 mil. So this will work for a typical oil change of 5 liters, correct?
Yes.
And 5 liters is fairly typical for most small sports cars. Maybe have the 5 liters, maybe up to maybe 8 liters, you need 2 bottles. But for something like £40, you've got a really easy way of protecting your very expensive investment that you want to enjoy at its best for as long as possible. Walter, tell me a little bit about your journey to developing microceramic.
I used to work as a mechanical engineer, in a big door factory. It was in the 90s, in the beginning of the 90s. And in that time, both Germanys came together and there was a huge demand on doors.
Yeah, okay.
And our job was to speed up the machines.
Okay.
And we have been faced with a lot of machine failure, especially bearings. And we also involved the University of Munich to have a look how we came out of this, because the factory runs 24 hours, 5 days a week.
Yeah.
And our job was to do also maintain the machines and look after the machines so that we have no stop between breaks, for the big breaks, for a holiday break.
Yeah.
And we have seen that the lubricant is not able to protect the metal parts, the bearings, or whatever is lubricated. And then we had a look, what we can do, to improve the lubricants.
Yeah.
And this is really my passion since now 30 years.
Yeah.
Now we are talking about the year 2024.
I know, yeah.
and we have a ready-made product in the market. Yeah, and we have done all the researches which is possible in the lubricant business. So we have done all testimonials which you can ever imagine.
Yes.
Yeah, from gearbox tests, trials, to cars on the dynamometer to examine the exhaust gases, 3D profiles, yeah, and all tests which is ever possible.
The fact that it's come from industry really impresses me, because a lot of products don't really need to work. They can just be something that, you know, you can buy and...
So I call it margin optimized product.
Yes. Whereas this product has been driven through commercial and industrial applications where the difference between adding it and not adding it is a commercial decision, and therefore made with the brain and not with the heart. Yeah. Right? So this is a product which has been through all of that testing. What kind of testing have you done with, you know, what industries and what type of mechanisms have you used to test the products?
Yeah, I hand over that to, for example, to the University of Munich.
Okay.
Yeah, FZG.
Yeah.
Company. This is a company up beside the university,
okay,
who developed all, I think, all the tests in the 60s, which is related right now to the lubricant industry.
Okay.
Yeah. So we have done a gearbox test. Yeah. For example, two wheels are working against each other.
Yeah.
Yeah. On the same temperature, on the same RPM. Yeah. The wheels are perfectly matching. Yeah. And we put it on the weighing scale. So after, for example, 90 hours or 120 hours, yeah, we measured again under different loads, different temperature ranges. Yeah. So we have seen a decrease of the wear of 20 times in that test, which is absolutely unbelievable. Yeah. And while adding to several applications, we have seen the same results.
Yeah. So I've got a question for you, Walter, and this is an interesting one. We've had a question from one of the viewers in the chat, which says, why, if this adds all of these incredible properties, why don't the oil manufacturers put this into their product and that's what you buy off the shelf?
This question every time comes, yeah,
okay,
on the table.
Yeah.
It's easy to answer.
Okay.
The car industry don't want that we enhancing the lubricants because they want to sell spares. Yeah, and together with the lubricant industry, they are making the specs which we have right now. Okay. So the highest specs, yeah, we know that we can do something better. Yeah.
Okay.
Yeah. And the main reason is the car industry don't want that because they want to have sold out spares.
So yeah, when you buy oil from the counter at the local motor factors, it comes with technical paper, and that technical paper has the specs on it, and those specs are driven from the automotive industry itself. Correct?
That's right.
Yeah,
that's
right.
Yes,
okay. So in actual fact, they don't have a shared interest in making the highest levels of protection.
Yes.
We rebuild engines here, and we see a huge number of failures on the engines that come into us to be rebuilt. Now, a lot of these are oil related. Very often they're oil related. When we look at the bearing shells, it's very clear to see, for instance, on this one here, how the oil has been dirty. But over time, so this is things like soot and combustion products, those kind of things, that build up over time within the oil, and they're very fine abrasive. So slowly over time, they're rubbing the wear surfaces. In the case of these bearings here, you've got an engine that has hardly done any work. This engine has run just for a few hours, and already you're seeing very deep scoring within these bearings. And this is because there are particles in here which are debris from metal that's circulated through the oil and has scored and scratched into these bearings. And again, this is the kind of thing that very quickly causes bearing failure. So we see this very often. Another example here, we've got bearing failure that's caused by lack of lubrication to the bearing surface. Maybe this was a momentary lack of lubrication. So for instance, during hard cornering, this is from a racing engine. So maybe during hard cornering, this bearing was starved only for half a second maybe. And then that's been enough to spin the bearing, block the oil delivery to the bearing, and then of course resultant extreme high temperatures and ultimately complete engine failure. Okay, so when we look at a heavily worn plain bearing like this, what are your thoughts, Walter, about what you see?
Look, plain bearing wear, yeah, has a lot of fathers, I would say.
Yeah.
This is related to first of the lubricant. Yeah. The lubricant film strength.
Yes.
Yeah. The type of the lubricant, the viscosity level under that certain temperature we have.
Yeah.
Yeah. So if we have a low viscosity, yeah, then the metal will, or the lubricated part will touch each other. Yeah.
Yes.
And then small metal particles will be taken out.
Yeah.
Yeah. And it looks like washed out. Yeah. So furthermore, we have deposits in the oil, soot particles, or hard varnishes, yeah, which is working abrasive. And everything has the same, I would say, picture here. Yeah. So what we can do is to enhance the lubricant with the solids.
Yes.
Yeah. To bring in a solid lubricant which spreads the metal parts from each other. Yeah.
Yeah.
So, and you need to know why a plain bearing is working. Yeah. Because to the position of the oil drilling, yeah, and the RPM, we are increasing the oil pressure up to 2000 bars inside. Yes. Otherwise, the engine will not run. With a 5 bar oil pressure you have, that plain bearing will not work.
Not run.
Yeah.
So essentially what we're saying is that the shaft is surfing on a wave of oil as it rotates. Yes. And that the very point of contact where that shaft is applying the pressure is extremely high pressure. So that point of contact is separated by a very thin layer of oil, and that's the only protection it has. That very thin point is so thin that if there are particles within the oil, debris particles, they can damage the bearing. Whereas if you have a very special type of particle, that creates a protection layer at that point.
Yes.